So to integrate this one, first thing I'm going to ignore the limits, then apply them in the end after simplifying the expression. Second thing, I'm going to outline the identities. For we know that cosh theta is equal to e to the power theta plus e to the power negative theta over 2. Then we also know that sine theta is equals to e to the power theta minus e to the power negative theta, everything over 2. Using this expression into our integral, we're going to have the integral of where there is cosh, we put its equivalent. So we're going to have e to the power theta plus e to the power negative theta, then everything over 2. Then we divide this by sine theta, which is equals to e to the power theta plus or minus e to the power negative theta, everything over 2, plus e to the power theta plus e to the power negative theta over 2. So simplifying this, we're going to have the integral of e to the power theta plus e to the power negative theta over 2 divided by, simplifying this, putting them as a single fraction, we're going to have e to the power theta minus e to the power negative theta plus e to the power theta plus e to the power negative theta, then everything over 2. So we'll see that we have e to the power negative theta, which is negative, and e to the power negative theta, which is positive. Then e to the power theta and e to the power theta, we can add them to have 2 e to the power theta. So with this one, we're going to say our integral is going to be e to the power theta plus e to the power negative theta, everything over 2 divided by 2 e to the power theta over 2. So the 2 and the 2 can cancel out, meaning that we're going to have the integral of e to the power theta plus e to the power negative theta, then everything over, since we are dividing, when you turn it into a multiplication, it's going to be multiplied by 1 over e to the power theta. Simplifying this to be equal to the integral of e to the power theta. So we notice that this e to the power theta, it's a negative, so we can say it's 1 over e to the power theta, then everything over, when you multiply this e to the power theta multiplied by 2, you get 2 e to the power theta d theta. Simplifying this further, we're going to have the integral of, so we're going to make the numerator as a single fraction, meaning we will say e to the power theta multiplied by this e to the power theta, meaning it's going to give us e to the power 2 theta. Since what we have is e to the power theta multiplied by e to the power theta. The base is the same, so we're going to add the powers. This will give us e to the power 2 theta. So since we have that, we can say it's e to the power 2 theta plus 1, then everything over e to the power theta over 2 e to the power theta. So just create some space here. This will be equal to the integral of e to the power 2 theta plus 1, then everything over e to the power theta over 2 e to the power theta. Simplifying this, we have a d theta here. Simplifying this, we're going to have the integral of e to the power 2 theta plus 1 over 2 e to the power theta d theta. So with this, since we have two terms on top and a single term in the denominator, we can split this expression, meaning we are going to have e to the power 2 theta over e to the power theta. So we can take this 2 outside the integral. It will be 1 over 2. So here we also have a 2 theta. Then plus 1 over e to the power 2 theta d theta. Simplifying this further, we're going to have 1 over 2, the integral of this e to the power theta and this e to the power theta will make 1. So it's going to be 1 plus, then this e to the power 1 over e to the power theta, we can take it up. We are going to have it as e to the power negative 2 theta, then d theta. So, integrating this now, we're going to have 1 over 2 open. The integral of 1 with respect to theta is simply theta, then plus the integral of e to the power negative theta. We simply differentiate the power. Then after differentiating the power, we divide it by the expression. So we're going to have e to the power negative 2 theta, e to the power negative 2 theta, then derivative of e to the power negative 2 theta is simply negative 2. So we're going to have over negative 2 here, then plus c. This one reduces to 1 over 2 theta minus e to the power negative 2 theta over 4 plus c. Now using this, now we're going to apply the limits, since we had ignored them at first, so that we simplify the expression. So we're going to have the limits that we've been given is negative natural log of 2 and natural log of 2. So putting this into 1 over 2 theta minus e to the power negative 2 theta, we're going over 4 is going to be, so we'll get the upper limit and place into the expression. So using the upper limit, we're going to have 1 over 2 natural log of 2 minus e to the power negative 2 natural log of 2, everything over 4. Then here we're going to subtract the lower limit, so it's going to be minus open 1 over 2. So since it's negative here, it will be negative natural log of 2, then minus e to the power, since it's negative here, for the power is going to be positive, so it's going to be 2 natural log of 2, everything over 4. So simplifying this, we're going to have 1 over 2 natural log of 2 minus e to the power negative 2 natural log of 2 over 4. Then for this one, a negative and a negative will be positive, so we're going to have plus 1 over 2 natural log of 2. Then this negative and this negative again is going to be positive. It will be plus e to the power 2 natural log of 2 over 4. Simplifying this, we are going to have 1 over 2 natural log of 2 of plus 1 over 2 natural log of 2 is giving us natural log of 2. Then minus e to the power negative 2 natural log of 2 over 4 plus e to the power 2 natural log of 2 over 4. When you punch this on your calculator, you are going to get an equivalent value of So this would be approximately 1.6306 as our final value.